Thank you all for coming today, and good morning. And I'm always amazed by the Android community, and Android community is always very serious community among if you see, because we are not a kind of community who has lot of quantity, but yeah, we always have a quality audience is what I have seen. So today we'll see how to debug and fix our Android apps performance at scale. So Android is like when we start our Android development journey, we start learning from the basics. We learn how to build small screens, how to build interactions. Then further we learn about how to make a network call from the application. Then further we learn how to build MVPs for the products. And this is how basic learning looks like. And then after certain time, we start getting a lot of issues. It may be graded issues, it may be some crashes, whatnot. And after your application reaches certain scale, your user starts complaining like, okay, your app is stucking, your app is having a lot of jank issues and all. Even if let's say we use the applications, we see some apps basically when you scroll through them, they basically start like stucking in between. So that's we are going to see how to solve them. Just a small introduction. I work as a senior Android engineer at Deliveroo, also GD for Android as I think Gaurav mentioned. And I'm an open source contributor and maintainer, and whatever I learn new, I write blogs about it on my domain. That's all. And what do you think? Like, what is the most dangerous phrase in the development? Any guess? The thing is like it works on my machine is the most dangerous phrase, because whenever we develop app, if it works on our machine, we confidently push it to production, but obviously reality is very different, right? And this is what happens in the case of performance. So the main problem is what makes Android very different from another kind of development, let's say web development, backend development. Whenever you develop from backend, you're going to deploy it on some server which has this XYZ RAM, XYZ processor, this container and whatnot. Environment is fixed, you know your scale. And in web development, you know that your users are going to use it on like Mac, Linux, Windows, and Chrome browser, Opera, like Firefox, a certain set of browsers. But in Android, it is very different. Your users have thousands of different devices. Some are using Samsung Galaxy S25, 424 Ultra, high-end devices. Some are still using Geo phones, which cost around 5K, having very low processing capabilities. And apart from that, your users are running different types of applications altogether in the mobile. Right? There can be hundreds of like applications which might be fighting for the resources along with your application. Many people might have been using slow, unstable networks. Now we are in Pune, we have 5G network availability, but maybe in rural areas, someone might be still using BSNL 3G, slow network, right? And older Android versions, so you can see like latest Android version is Android 16, but not everyone adopts to it very quickly. Maybe most of the population at the moment is still on Android 13 or 14. Many haven't yet even updated to 15. And if you are Android developer, so you always set minimum SDK version to some 24, 21, right? You might have seen in your code as well. So we have to support older Android versions as well, which might be very challenging to maintain as well. And again, low battery, thermal throttling and all. Users have variety of batteries. Some phones provide good battery backup. Some phones are not capable, like they get discharged in maybe mid of the day. So there are a lot of challenges like this. So that's why Android is very complicated. And the kind of problems user faces is like, let's say this is your application. Then your users start getting and application not responding error. I hope you have seen that error, right? ANR basically, we call it ANR. Can anyone tell me like where ANR occurs? So if application is like UI is running and if it is stuck for 5 or more seconds, the error comes. And let's say if you are running it on service or broadcast receiver, then it's 10 seconds. So we get application not responding. Then we get out of memory error. Out of memory error means you are basically maybe your application is allocating a lot of memory, but we are not freeing it. Garbage collector is not running. Like there are a lot of complexities here as well. Then after these two errors, then we start facing like freezing screen, slow app. When we click button, the word for app pauses, and after certain time it just releases. Seems like किसी ने धक्का दे दिया, right? So that's how we face it, and then this leads to bad reviews and low ratings. आप किसी भी ऐप में चले जाओ, you will see lot of performance rate issues की ऐप अटक जाता है, हिंदी में लिखते हो, right? और कुछ लोग तो गालियाँ भी लिखते हैं उसमें. So then this also leads to uninstallations, right? And it is basically poor for retention as well. So because I'm also telling because previously I was working at Paytm and we have a lot of performance issues for QR scanning there. It was not working for low-end devices. Now the problem is all developers always use boot devices for testing. You are testing it on Pixel or Samsung or boot device, which has like octa-core, 16 GB RAM, 12 GB RAM, 8 GB RAM. But we have to care for devices which runs on 2 GB RAM of devices or 4 GB RAM of devices as well, right? We also have to make sure that they are also having good experience. Otherwise, what happens that it is always like mouth to mouth, we can say conversations or promotions. Let's say if anything is going wrong, then उसका क्या बोलते हैं प्रचार बहुत जल्दी हो जाता है. Basically, you will not recommend that app to your friend, right? And then business is impacted because then low engagement होता है, conversations नहीं हो पाते, and basically it also affects the brand reputation, and it becomes like a norm that that app is slow app. So that's why performance is required, and basically the slow app is a deleted application. And since you already know why error occurs, you might have seen this kind of logs in your application while debugging, or whenever you have a look at console, you might have seen that okay, skipped x, y, n frames. Application may be doing too much work on its main thread. So when you see this, you should actually take care of it, because then if you are seeing it frequently, then it means your application has serious performance issues. So yeah, this is the agenda for the today's talk. We'll see what are the pillars of performance. We'll see how to profile the application locally. Then we'll see how to profile our Jetpack Compose application. By the way, like how many of you have started using Jetpack Compose in your applications or using it in company? Cool. So that will be also helpful for you. Then we can see how to perform automation for the performance testing, because obviously this performance thing, it may seem interesting, but it is actually interesting, but sometimes you may find it boring as well, because then you start spending a lot of time with this performance only, and which can block your product development as well. And at the last, we'll see how can we observe this at scale. So what makes app performant? So there are these 4 pillars of performance. One is rendering. So whatever you see on the UI, it should be very smooth, right? Now your device, your users have devices of let's say 60 Hz refresh rate, 90 Hz refresh rate, 144, 120 FPS refresh rate. So as your refresh rate increases, your smoothness of the app, smoothness of the rendering increases. You start seeing more and more frames. So your app should be able to cover all these scenarios. Like your app should perform well on all these supported FPS. Your app should fight against jank. Then we have a compute, like efficient CPU usage, doing work without draining resources. So for example, your app is using a lot of resources. It should do it is doing network calls. It is doing some background jobs, etc. Like a lot of things. Like we know, like in our like whenever we do product development, there are a lot of things going on in the background. Analytics, that on when you tap on user, like data जा रहा है, वो कहाँ जा रहा है वो नहीं पता, चाइना जा रहा है इंडिया जा रहा है, right? So that's all. Memory, we have a stability, preventing leaks and crashes. So what happens with each variable you declare in the application allocates some amount of memory, right? But it is not getting filled, then every obviously it's proportional to RAM actually. Every app has certain amount of memory usage allocated by the Android operating system, and if you go beyond that, you start seeing out of memory errors. How many of you have not seen out of memory errors in your Crashlytics? Everyone has seen maybe. Cool. That's normal, I guess. And I actually every app faces this. It's not like we can completely prevent it because there are always some limitations. But yeah, we can try to reduce them if they are coming in more capacity. And there is battery. So battery performance is also necessary actually. So I think we all are Android engineers and we might be using Android phones as well. So sometimes you may have observed that after installing certain XYZ application, our battery starts draining quickly. Then would you keep that application always open? Or sometimes we take a decision, okay, let's uninstall this app, like if there are alternatives, correct? So that's why maintaining battery performance is also necessary because otherwise users will not think before installing it. So these are performance aspects of application. But today we'll see. Today we'll majorly focus on the first two pillars, like which is rendering and compute, because obviously it will not be possible to cover everything in this just a one session. So we'll see what Android Studio provides to us for this. So Android Studio provides us this tool called Android Studio Profiler. How many of you have already used Profiler? Cool. So I think it will be very interesting if you start using it because then this is how you will be able to improve the performance of application. Just like we use Logcat for checking what is happening in the application. We use what else we use? I think layout inspector we use for debugging the UI layout, like what is happening on the UI layers and all. Similarly, Android Studio Profiler gives you insights on what is happening at what time inside your device, and it is not just for your application. You can literally inspect what your Android devices are doing at the moment. I mean, you will be just able to see the traces, like what is happening at what time. Let's say, okay, some application is accessing camera, then you will be able to see that there is some application which is using camera resources during this period and all. Similarly, so this is how this Android Studio Profiler window looks like. We'll see what's in detail. So for example, this is how a system profiler looks like. I'm not sure it is visible clearly, but I will just try to explain. So for example, once you let's say profile your application, you will see something like this, and in this you will see kind of traces. So for example, you will see all the threads started in your application along with main thread. So obviously we are multi-threading. In applications we use multiple threads. Your main thread is your application's package name, and all other threads are basically like maybe created from Firebase or let's say you are using coroutines, RxJava or maybe you are using your own thread. So these threads will be created and these threads will be like this. You can see this. There is this profiler. So basically, this is one thread. This is one thread. In Android, there is a render thread as well, which takes care of rendering your UI. So you start seeing like, for example, this is the span and what is happening in the span. I mean, we'll see it in detail. I will show you how it looks after zooming, but this is, we are just taking overview now, like how it looks. And by the way, if you are not able to read this is the janky frames. Janky frames means it gives you the information like how many janks are occurring in your application. And whenever you see these red lines, it means these are the janks in your application. By the way, can you tell me like, or anyone can tell me what is exactly jank? Or when jank occurs on the UI? Cool, we'll cover it, no worries. And we'll take a look at it later. Then we have a memory profiler. So obviously when your application becomes very big, lot of classes, multi-module architecture and all, it is very hard to basically check whether you are using memory based practices or not. Correct? Let's say, okay, you all are aware about dependency injection as well, right? We use dagger, read, or anything. We also make sure that some instances should be singleton, some should not be singleton, right? But let's say if you miss that singleton annotation, then what happens? Whenever you try to access that object n times, let's say we access that object 5 times, then 5 times instance will be created, right? So similarly, you can actually use a memory profiler to check how many instances of certain classes are created in the application. So when you run the memory profiler, it will actually give you all the list of classes. It will show you how many allocations are made for that particular classes and how many were retained as well. Retained means basically kept in memory. And you can actually also trace from where this is getting allocated. So for example, if you click on this app compact text view, and there are a lot of, let's say 7 instances allocated of app compact text view. So once you click on it, it will give you a list of all the 7, and you can trace them from where exactly it is getting created. So from the trace you can see it is getting created from main activity linear layout. It means it's a part of UI. So if you are using dependency injection and let's say you did any mistake in it, obviously it is not easy to find, not even in PR reviews, but you can use memory profiler to detect such issues so that this will ultimately impact your out of memory errors. So in our application, like recently we found that we were using this shared preferences. It was inside a class. And that class was not annotated as a singleton. So what was happening, whenever we tried to access that class, it created n shared preference instances. And obviously shared preference is what, like, it reads and writes files and all. So it was not doing that. I mean, even if we were doing it on the background thread, it was not stacking the application, but it was impacting to the memory. So once we fixed it, actually it improved our 60 MB of memory. And this was actually a good lesson as well. So definitely try memory profiler whenever you get time, and you will see a lot of impacts as well. Then we have a call stack. Call stack is not that helpful, but you can just take a look. Call stack just gives you an info like how much operations are happening on which thread at what time. So for example, this is your main thread. This is render thread, these are render thread, then we have async task. Async task is basically the old framework. I mean, if you are from coroutine era, Arja era, you will not remember async task. Even I haven't used async task in my life. But yeah, so call stack basically gives you info like what's happening at what time. And then here comes Java Kotlin allocations. So for example, this is the advanced level of memory profiling in which you can check, it gives you a real-time info of how many Java or Kotlin allocations happen from the time. So for example, you start recording the profiling, and after let's say 10-20 seconds you stop it, and in that time how many allocations and deallocations happen, it gives you that info. So for example, you can see this graph. So this is the memory graph, like this amount of memory was allocated. It is around 200 MB. And after certain time you can see the spike in the memory usage, and suddenly it is going down as well. And whenever you see this dustbin icon, it means it was a garbage collected. GC was called. GC frequently gets called in our application, and if you are, let's say, allocating a lot of memory, GC is again like frequently called, and basically whenever GC is called, your application also starts stacking. So ultimately memory performance is also directly proportional to our overall application performance. And in this as well, you can see how many instances were allocated for the Java or Kotlin class, and how many deallocations also happened. So for example, how this will help you. So let's say if certain class is allocated but never deallocated, it means it remained in memory, and maybe it is causing memory leaks. So this can also help you in finding memory leaks. And I think you all must have heard about leak canary, or all will be using. So leak canary does what? Leak canary detects Android class memory leaks. So let's say if you are using activity fragment, and if activity fragment is leaked, basically it is never garbage collected. So that also keeps on increasing your memory usage. And we have native allocations. I mean, this is just for reference. I think we will never need to use it. If you are working with C or C++ code inside Android, is anyone using NDK? I think mostly we never need to use it. But yeah, let's say whenever you're using mobile barcode scanning or any kind of machine learning library in Android, it is mostly written in NDK, C++. So this kind of allocations you can measure with this native allocator or native library. And there is this live telemetry. So Studio Profiler gives you option of live telemetry. This is just a kind of telemetry that tells you what is the overall usage of your profile CPU and memory together with not much details. It just shows you graph. It will not give you details like what exactly causing issue and all. It is simply a graph. So for example, you can see at certain point there is a spike in CPU usage, again spike in CPU usage, and at that point memory usage is also increased and again decrease. So you can just have a look. So this is actually a basic step. Maybe if you are feeling that your application is consuming something, maybe first step you can do is like you can do live telemetry. You can verify if your application is spiking at some time and not going again down. Then maybe you can start further profiling. And then here comes layout inspector. So obviously now you are using Jetpack Compose. So in Jetpack Compose, Jetpack Compose is very easy. But again, when you start building complex UIs and applications, you might start feeling like it is not as easy as XML was, right? Because there are the recomposition and all these issues, and recomposition makes apps slower. So you can use layout inspector to basically check how many recompositions has been happening to your Jetpack Compose UI. So recompositions are not bad, but if it is getting recomposed, even if content on the UI has not changed, then it is a problem. So layout inspector can help you to check this recomposition issues. So this is what Android Studio provides, and as we said, like today we focus on optimizing CPU performance. So previously I asked you a question like what is a jank? So there is basically a 16 milliseconds rule, very basic rule. So let's assume a smartphone displays smartphone has 60 Hz refresh rate. So what does that mean? It has to produce 60 frames every second. Okay, 60 frames every second. And let's say device is 120 Hz, it means it has to generate or show 120 frames per second. If device has 90 Hz refresh rate, it means it will show 90 frames per second. So let's assume for 60 FPS, 60 Hz device. So it means if you see this math, every frame should be rendered within 16 milliseconds there. So our application is running, and for example, you see all the smooth animations and all happening inside your application. So it means it is generating a new frame every 16 milliseconds. Obviously, it is not visible with our naked eyes, but yeah, it's happening under the hood. So it means, in short, simple thing is this gives your app a strict budget of about 16 milliseconds to do everything needed to produce a single frame. And similar math is applicable for 120 Hz as well. So for example, if your device is using 120 Hz, then it means as per the mathematics, it should produce a frame within 8 milliseconds. Our time gets shorter as frame rate increases. So if we just talk about the 16 milliseconds rule, then it means, let's say this is a simple animation. Okay, these are the frames. Let's say this is one frame, this is one frame, this is one frame, this is also one frame, and in between, let's say our app was doing something on the main thread, and that's why that frame was not able to complete in 16 milliseconds, but it took 40 milliseconds. So how this animation would look like? It will look like this. So for example, you start from here, It will go here and it will directly start from here. It will not show you the middle wala red thing, because at that time you were doing a lot of operations on the main thread, and you were basically device was not able to, or app was not able to render the UI at that time because you blocked it. So that's the basic rule, 16 milliseconds. So if you are performing any kind of operation on main thread which is taking beyond 16 milliseconds, it means your app will start slow down on the UI. So the simple thing is, if you know that certain operation is taking a time, offload it to background thread, coroutine or RxJava if you are using. But yeah, I think coroutines is now a first class choice for multi-threading. So would recommend that as well. And in that as well, you have to use properly use this thing, default dispatcher or IO dispatcher. If you do it on main dispatcher, then this will not work. This will stay the same. So yeah, this is how this animation will look like. And now let's take a look at Shreyas, which is an Android pseudo profiler which we recently saw, but now in detail. And the first rules, profiling rules. So what is, by the way, profiling is, just like whenever any bug occurs and we try to debug it, we call it debugging. And whenever any performance issue occurs and we try to debug it, it is called profiling. So there are the rules of profiling. Always test it on your physical device, real device. Because if you test it on your emulators, then what happens, that emulators are basically virtual machine inside your computer system. So it uses or harnesses power of laptop or your machine. Let's say I am using MacBook, so it will basically run on MacBook's machine. So obviously it will be always so fast. So it will not give you the real world feedback as your users do. So always test on your real devices, connect your device by USB, and prefer testing on low end devices. Now if you say कि चलो S24 पे performance test करते तो S24 में तो सब smooth ही चलेगा, right? You have to test on, let's say, low end devices जिसमें बहुत कम RAM है, कम CPU है, quad core है काफी. Once you start testing on these devices, and if you make experience better for these devices, ultimately it will work on every devices. But it will work on every device with good thing. And do CPU profiling on release equivalent bit for real simulation of user experience. So for example, okay, we have a debug flavor release bit type in our Android, right? So debugging is always slower because it is doing a lot of things. So profiling, generally we do crash debugging or any kind of debugging, memory profiling in debug application. But in when we do profiling, it should be always on release equivalent so that you can see what your end user might be seeing after this. So these are the three rules of profiling. And then once you do profiling, this is how it looks. So for example, your device is octa-core CPU. It means it will have 8 threads, 8 CPUs. So it will actually show you which CPU your app is using when you are running your application or running some use cases. It will show like what is happening on each CPU. This is just a high level view, not necessary, but just projected for the idea. And then once you profile it, it will start showing you the app insights, like what was happening. So for example, this is your application and you did profiling, and let's say this was taken from Sunflower Google sample application. You can see like at the top it is showing janky frames. It shows like how many janks occurred. By the way, disclaimer, no, it is not possible to 100% eliminate janks. Even if you run hello world program Android का start वाला, उसमें भी I think 10% janks आते ही हैं. So it is not problem of us, it is actually problem of overall Android ecosystem. Because in iOS we never get issues like this, but in Android we get because of these hardware limitations and all. So it is not possible to completely eliminate janks, but yeah, we should try to keep janks within 15 or 10%. If it is going beyond 20, 25, then it means it is our issue, it is not our issue. Then it starts showing you like what is happening at what time. So for example, you can see here choreographer is running and choreographer was performing RV fraud. RV means recycler views fraud. So at that time you can see like recycler view was going on, and maybe that is basically taking a time. You can see on the right side you are seeing the info of it was the jank type of deadline is. It means deadline was what? We recently run, we have a 16 milliseconds rule, right? So expected duration to render was 20 milliseconds at max. It should have been rendered, or that operation should have been performed within 20 milliseconds, but it took around 30 milliseconds. It means 10 milliseconds extra, which caused that frame to skip altogether. So even if you take 1 or 2 milliseconds extra, it basically skips the whole frame. That causes the janks. So this is how profiler looks like, and we'll see in detail how to use this. Okay, that was a system profiler, but there is also one more tool which I personally use a lot. It is Perfetto. So basically, Android Studio System Profiler is integrated in Android Studio, and Perfetto is a kind of tool which is used for Linux and basically Linux profiling, and Android is ultimately a Linux, right? So it is a web tool for debugging the performance, and it gives you the all your applications info. Sorry, not applications. It gives you a device info. So for example, in earlier slide you saw there was a system profiler. It was just giving you the info of your application. It was a Sunflower application demo. But when you use Perfetto, it will actually give you the info of your overall device, like what is happening on your device. Let's say your app as well, but it will also give you the info of other apps, what they are doing. I mean, you won't be able to check their code, check their traces, but you can just check like how many checks are occurring on other apps as well. So I use Perfetto because it's very easy to navigate and use. Android Studio Profiler requires knowledge of a lot of shortcuts, keyboard shortcuts to know, and basically I'm lazy at it, so I use this Perfetto because both use the same format. There is this trace file. If you import that trace file in Studio, it shows you the application specific info. If you import it in Perfetto, it will give you the same info. So both has the same format. It's just that one is integrated in Studio, one is directly available. Like you can just say, oh, ui.perfetto.dev. It will launch something like this on you. And by the way, you can also profile your applications from Perfetto. So once you go to ui.perfetto.dev, it will ask you like whether you want to profile your Android app, Chrome OS app, or Linux app. And if you connect your physical device with USB, it will. You can select your option. You can select what you want to profile, like CPU, GPU, power, memory. You can select and select, and it will only give you that info. And once you do that, you will see the same traces as we were able to see in the profiler. So now, this was just an overview. I mean, this is not, we are not stopping here. We are going to see it in detail. But before that, let's understand this from the basics. Now we should see the basics of tracing. So what to look for traces? So whenever we will use profiler or system profiler or Perfetto, what to look for it? We should check whether all of the application frames are within frame timelines or not. So as we just previously learned, 16 milliseconds rule. If any frame is taking more than 16 milliseconds, then it means it is a red flag. Whenever you see red in Perfetto or profiler, it means it is a jank. So that should be our first priority. And always look for our package only. Like mistakenly, if we start looking at another application, then obviously we will not be able to improve the performance. Mainly look for main thread as well, where our main logic of app runs. Look for long running tasks here, and have a look on render thread, like if system is properly drawing your application's resources on UI or not. Because sometimes it may happen that your application is not actually rendering something on the UI, but render thread is still active. It means maybe you are recomposing something which is not required. I mean, content on UI is not changing, but it is still doing a lot of work on render thread. It means that is also not good. And we should look for surface flinger as well, where the system service that composite everything onto the screen. So whenever we click on something, or whenever we perform operations on hardware, like touch screen, our screen is also hardware, camera is hardware. So can get updates here, or you can see that how it looks. So for example, this is a simple trace. Now this is a Perfetto UI, and this is our application. This is the application's main thread. So you can see at the top it is an expected timeline, and niche there is an actual timeline. So expected means it will always say that your expectations are like 16 milliseconds. Your frame should be rendered within 16 milliseconds. But you can see in actual it is taking like one frame is just that just this. I mean you can see this frame, its length is like this. It means one frame should be like completed within that span. But you can see this it is taking whole this time to render. So if your app is taking this much resources at this time, it means you can see like basically there is a jank within application. But now how to find it? If you look at the traces, it is saying choreographer do frame is running. By the way, if you know, like choreographer is responsible for rendering everything in our Android system. So every 16 milliseconds, every new frame, like choreographer draws it. So now you can see choreographer is working, like it is drawing something on main activity, which is our application's main activity. But now, how to find who is, what is culprit behind it? So that you can see. So for this we can add traces. So obviously system trace will only show system traces. It will not show your application's code here. But then you have to work on it to let your application's code reflect here. So for example, you are running certain methods, so that methods will get reflected here. And this is how studio profiler will look like. So similarly what we saw in the previous, this was a Perfetto UI, this was a studio profiler. Both are the same. And you can see, for example, as I said, like we system traces. So for example, you can see this is taking this much time. Let's say this is activity on create. You know, we have a application lifecycle callback method on create. So if jank is happening on create method, you are able to see your application's on create is taking, let's say 50 milliseconds of time. But how to find which like what you have written in code that is taking 50 milliseconds, that we will now see. So we have a class in our Android system that is trace. This is a part of standard Android SDK. So you can say trace.begin section. You can give any name to the trace, any name as what you want. Basically, the name should be always like refer to whatever operations you are performing. And whenever you are done with the work, let's say whatever code you have written, and after that you should say trace.end section. So this will create a span inside your application. And now after this, whenever you trace your application with system profiler or Perfetto, okay, again, you know, this is a standard Android SDK class, but after this, you know, we have Android X libraries as well, which has, you know, Kotlin Lambda support. So for example, you can directly create a trace like this. You can give it a name, and inside a Lambda you can write your logic, and it will trace it for you. So you don't have to manually call trace.end section. It will automatically end under the hood. And once you add this, so for example, earlier we saw applications on create was doing something, but we don't know what it was doing. Now you can see when we added a trace, that trace gets seen here, my on create. You know, in previous slide we named our trace as my on create. So that trace will be visible here, and like this, when you start using this tracing in your application, you will be able to see your code blocks inside profiler, and then you will be able to debug like which component is taking more time to render, and like which component is taking more time on main thread. So for example, Perfetto also shows your application startup trace. So application startup trace, whenever we click on the application icon, and you know our application is launched. By the way, startup time is also important for us, right? Do you use any kind of application that takes a lot of time to start? Basically, we are always annoyed with such experience, right? So if you want to start application and it is not starting. So Perfetto shows you startup time in the Android app startup section. You can see, for example, this is the package of our application, com example performance, which we'll see now. This is automatically created by Android system. Like we do not need to do anything manually. And you can see, let's say this is taking around, let's say, 500 milliseconds. Now, obviously, if you have to check what is your application doing to, and it is taking 500 milliseconds, then you can check with tracing as well. So, for example, you may know the rule like okay, we should not do a lot of operations when our application is starting, right? Can anyone tell me like how to reduce it? Like
Startup library.
yeah, correct. Startup libraries. So let's say there are we use dependency injections and all. There are a lot of libraries we use in the application, but not all libraries are going to be used at the very early phase of your application, right? Maybe whenever you go certain screen, only then you will be using some of the features of some libraries. So it is always good to offload other like initialization of other libraries at the runtime. Like it is not necessary to do it early. So maybe what you can do is like okay, you can add traces for the let's say your application has on create method. You see like what all dependencies are getting initialized. Maybe you can start traces. You can add traces for all the library initializations, and once you add these traces, you'll be able to see okay. Let's say I added some traces as we saw in the previous slides. I will just add traces like okay, init library A, init library B, init library C. So you will be able to know why our application is taking more time because these libraries are getting initialized. And this way you can basically then decide which libraries are necessary to be initialized at start, which can be deferred next, maybe in the next screen or maybe after our main screen has been rendered. Inside that as well, there is a parent-children relationship here. So for example, if library A is using, again initializing another library, let's say A1 library. So we can also see those traces and we can see whenever the application was starting, these libraries are getting initialized. And then we can take this in. If these libraries are not necessary, we can just defer it and basically it will help improve your startup time as well. And now let's see some examples. Now please actually see the code. So you can see there is this screen. It has some winner profile, and you can see it is constantly getting animated. I will explain it by pausing it. So for example, you can see there is this screen in which title is basically animating infinitely, and by the way, this is designed in Compose. And whenever the user is clicking on that button, get winner profile, you can see animation stuck. And achanak se content got loaded on UI, and again that animation continued. So it means what we see here, whenever button is getting pressed, something is happening, which is basically like stopping our applications to work, like stopping animation. Basically, it is stucking our application, and suddenly something is getting loaded on UI, and then it starts working. So this is bad, right? If this happens for let's say more than 5 seconds, as they said, pain or will occur in the application, and then there will be a lot of crashes in your crash tickets. So how to solve this? So for this, we can use profiler. So I will now show how this looks. So I will go to ui.perfetto.dev. I have already traced this, so I don't have to trace it again, otherwise actually it will take a lot of time. So what we can do is
Did you simulate the scenario forcefully?
correct. Because this is a demo, right? So in demo we have to prepare bad things and good things both. So you can see why it is happening. So now I have loaded this in Perfetto, and now we will just navigate to our application, which is this example performance application. And now you can see the janks. Okay, in the video you saw jank is happening when you click on that button. So that we can see looks like this is that jank because this duration seems bigger. So if you click on it, it will actually give you the details of what exactly happened. So for example, it says there was this frame and it took around 286 milliseconds. It means it should have actually taken just 16 milliseconds, but it is taking 286 milliseconds. It means it is a serious issue, and that's why it is stuck in your application. But if you let's say zoom that trace, okay, if you zoom that trace, it is showing you that the frame was running. It was using some compose code. By the way, I will actually share this presentation as well with you because I think you might not be able to see the text here. But you know, whatever composable functions we have created in the application, it is showing those names here. I am not sure if I am able to zoom it. Like, is it visible for everyone? Or I think it will not be. It's the resolution problem. But yeah, so for example, you can see it is taking more time. Like as we go through the traces, these are basically compose traces. By the way, the base part compose does is we don't need to add custom traces for. Magnifier I can try. I've never used it before. Like this, right? It Perfetto is a custom override. So sorry, I'm not able to use Magnify because maybe my machine has no software for this. Yeah. But yeah, base part of Compose is that you don't need to add custom traces to your application. It automatically creates traces for your composable function. So for example, our application has composable function called let's say card. You are using material 3 and card, so it will show like card is taking this much time. Then we have a winner profile card. So you know, in that video you saw there was a winner profile displayed after a certain time. So it is saying that is taking time because it is taking time in image decodation process. So you can see there is this image decoder which is taking 203 milliseconds. Now, why image might be taking that much time to get decoded? Because then maybe that image is so huge that if you see the video, so this image is very small in the UI, but maybe this image might be huge in the resolution. Maybe it might be 4K image. Like, do we need to really show the 4K image here? No, because this is just a small screen, right? So maybe we can optimize on this. And second issue is whenever we, our winner profile title was continuously getting animated. So you can also see the traces for these animations. Here. So you see these small lines. It means these are the animations, and animation is perfectly fine. Like there are no janks in the animation, but janks only occur after we clicked on that button. So you can see animation was going on, and suddenly animation stopped in this time, and then we are displaying this. So it means something gone wrong when we click this button. I think this is the duration on which our animation is not running and our application got stuck. But now we are not able to see what exactly happened at that time, right? We have to debug that. Now with this clue, we are able to see we have to debug our on-click functionality basically. Like whenever that button is getting clicked, we have to trace it. Because animation was running perfectly fine until this. So in code, basically what we can see is, I will go to the simple activity, and this is our composable function. So on click, what is happening? I can zoom this now. Yeah. So on click, it is launching a coroutine scope. Like okay, we are using coroutine, still issue is occurring. It is setting some states in the compose, and then it is calling this load winner profile. This is a lambda, I guess. I will show you. So this is a composable function. And this is the load winner profile. And what is this load winner profile is doing? It is calling again load winner profile here. And now I have created a variance in our application, like optimized or non-optimized flow, because then you can also simulate once you get this repo. Actually, I have a GitHub repo for this. I will share that link at the end, or maybe I will upload it after this session. So just to simulate, if you set this optimized boolean flag to false, it will basically call jank in your application, and if not, it will show you as it is. So what is happening in the else? This is not non-optimized flow. Basically, it is generating 1 lakh users having an image, and then it is returning the winner profile. And so we are creating the users of 1 lakh users, and if you see the get winner profile method, it is then going through all the 1 lakh users. It is sorting them by followers, and like user having most of the followers but having minimum following, it is sorting it. So you can see like there are 1 lakh into some like 1 lakh iterations happening on the device, and maybe that's why it is janking a lot. Also, if you see, user avatar is always avatar 4096. If you remember previously we saw that image rendering was itself also taking more than 200 milliseconds. So if you see, if you go to this image, it is actually 1.454 MB image. It is a 4K image. 4K image is not necessary for an application, right? So how to debug this? Now we know that on click of on click, it is calling this method. So simply we can actually trace this. Okay, my copilot is working well. I don't have to type much. I can simply add a trace here, and okay, now it's not giving suggestions. I don't have to type this. Cool. So once I do this, basically this part of code will come inside a trace called load winner profile. And now after this, if we run our app with profiler, I have a trace for that as well. I have saved all the traces. I will simply trace it here, like this, drag and drop. Just drag and drop works here. And now if you go to our application, so you can see, okay, sorry. So now this is our animation frame. Animation is perfectly going on. And now when you click the button, you can see now load winner profile is coming here. So it means you found the root cause of your thing. And you can see now this load winner profile is taking around 1 second. Like it is iterating through 1 lakh users array. So obviously it is basically janking your application for 1 second. It is holding your application for a second and then loading it. So how can we fix it? So let's say if you see optimized flow, this load winner profile optimized. Now we are doing it on the coroutine. Coroutine default dispatcher. अभी इसमें 2 लाख 10 लाख जितने यूजर्स बनाने हम बना सकते हैं, right? Because it will happen on the background thread. And now after this, let's say we trace how it looks. So after fixing this code, you can see now there are no janks in the application. This is our main application, and you can see everything is pretty smooth. No red flag. Everything is green here. And this is how simple tracing looks like. Yeah, just like we do TDD, trace driven development. Anyone do here? Like, okay. So just like test driven development का फंडा क्या है कि we write test before actually implementation, and then we implement until our test passes. Similarly, profiling का ऐसा होता है कि okay, now measure first, impact देख लो, fix it and again trace it and verify if everything is well. So this is how we fixed our performance for this. And once we do this, it is very smooth. Now, whenever user clicks on this get winner profile, you can see it is loading. It is properly showing loading and smoothly loading the UI. Now this time there were no janks. The trace we already looked. Trace was fine. we didn't saw any problem, and you can see visually as well there are no issues. Everything is loading smoothly. So this is how simple profiling looks like. And then let's say there's this next UI. This is the complex part. So now, you know, we always get complaint कि तुम list में से scroll करते वक्त problem आते हैं. Now why these issues are coming? So again same, you know, we were using 4K image. So in recycler view, we should not use we should use optimized images. So for example, if you are showing छोटा सा image, मतलब you can see the size of this image is very small here. Like user is not going to zoom it. So why to show 4K image? Like you can actually show the required width of images. And if you profile this, you will be able to know whenever user is scrolling, then these red frames are occurring. Now this is Android Studio profile. We are not using Perfetto here. It's just because I don't want to get biased with Perfetto. You can use anything you want. And by the way, recycler view library creates its own trace. You don't have to worry about its trace. So for example, whenever you perform scroll, it will add a trace called RV scroll for us, so that we can profile. Now you can see, I mean you won't be able to see, but yeah, this is RV on layout. So RV on layout means recycler view जब layout render करता है तब वो jank आ रहा है. So वो क्यों आ रहा है? If you click on that trace, it will actually show you. So this is a top-down chart of this trace. Android Studio also helps you in sorting the traces. So you can see कि जब भी recycler view का on bind view holder call हुआ, तब एक resource JPG file load हुई, जो image है हमारे basically user की. That image is taking around 119 seconds. By the way, this is microseconds, so ideally this is 119 milliseconds. So with this, you can see, okay, your recycler view has some issues with rendering that image, and once you fix it, there is also a flame chart option. So flame chart shows you कि क्या-क्या operations perform हो रहे हैं हमारे application में, क्या-क्या operations perform हो रहे हैं on that CPU thread. You can actually check what is taking more time with this flame chart as well. So it is showing that RV on layout is taking 167 milliseconds. And once we fix it, fix was same as we were using 4K image. Now we just replaced it with small image, जो I think 5-10 KB का होगा, which is just maybe 100 by 100 size का instead of 4K. And once we do that fix, now you can see अपन smoothly scrolling कर पा रहे हैं, no issues at all. So this is how this looks like, and this was just an example. But let's say your application is doing some complex work. Like for the demo, I prepared a simple example of image, but in reality there can be variety of issues. For example, if you are using linear layout, फिर उसके अंदर और एक linear layout, उसके अंदर और एक linear layout, फिर एक frame layout. You know, there are a lot of nesting, layout nesting. Then also this kind of issues occur because whenever you scroll, new layout is created. It requires a parsing and all. And maybe if you replace it with constraint layout, then overall time will be reduced. So these are just examples. I mean, you know, there is no perfect problem or perfect solution for this. It depends on your use case. And yes, this is how it looks. And now, since many of you use Jetpack Compose, the easy part. So recently we were able to see Jetpack Compose traces in our application. So these are not already available. You need to include this library in your application, which is like Jetpack Compose runtime tracing. So once you add this library, after adding this library, when you profile your application, you will be able to see Jetpack Compose traces in your application. Like this. This is taken from Android Studio. Sorry, this is taken from official website of Android. So once you add a library, whatever Jetpack Compose code is getting executed, you will see like, okay, which composable is taking how much time to render on the UI. If you are scrolling through lazy column list, so it will show you kitne recompose. So for example, if your XYZ composable is recomposing again and again, so you will see each trace of that composition कि इस recomposition में क्या हो रहा है, उस recomposition में क्या हो रहा है, nth recomposition में क्या हो रहा है, you will get to know about everything. So For example, now you won't be able to see this, but yeah, whenever you get access to slides, please have a look. These are basically composable functions which we use in the application with fully qualified package name. So for example, similar example, let's say we have this kind of, now previously we saw the list which was in recycler view, similar list in Jetpack Compose. You can see there are issues in scrolling the image, scrolling the list. Now we try to debug like what is happening, and whenever we see Perfetto, we'll see there is this there is this lazy, we are using lazy column. So in lazy column we are using this, we have a composable called user item, and user item is using material regard, then surface, and you can see at the top, at the very bottom, it is getting painter resource, again that JPG image. So you can see that JPG image decoding is taking time, which is around 788 milliseconds, correct. So now you get the problem that okay, this is the resource loading time, and once you fix that resource again here, you will see that user will be able to scroll this without any issues, no janks. So, but yeah, like I think Jetpack Compose profiling is a lot easier than profiling this recycle view and all, because for other XML layouts and all, you need to manually add these traces. In Jetpack Compose, you don't need to manually add traces. You will directly see your composable traces here. So this is how it looks. And maybe after fixing the performance, you can see now our user item is just taking 15 milliseconds to run. It means 1 millisecond कम use कर रहा है. मतलब actual जो limit है उससे 1 millisecond कम, because 16 is required, but 15 में काम खत्म करता है तो बच रहा है basically efforts. And now this is very tedious task, right? We'll again and again not do this. So for example, if you fix the performance, अभी कोई नया developer आता है, वो कुछ breaking changes कर जाता है and maybe फिर से performance खराब होने वाला है. Now every time we cannot spend time on doing this all profiling and all stuff, right? We can automate it. So for this, we have a Microbenchmark library from Jetpack. It is a Jetpack library for running performance test. Just like we run unit test or UI test. By the way, have you run UI test as well? Espresso, automation and all. So performance test also looks like this. It runs your actual app and measure user's real journey. So for example, it can give you like how much your application is taking when it is launching, what is the UI performance and all. And the best part is you can run it on CI as well. So for example, if you are using GitHub Actions, Bitrise or any CI, Circle CI, Jenkins, CAO, you can automate it, and whenever any kind of issue occurs, it will directly raise it. So you don't have to perform operations on it. So this is how simple benchmark looks like. So for example, this is how we can write a test. We can add this benchmark rule, and on that benchmark rule, you can give your package name of your application. You can give what you want to measure. You want to measure frame time metric. Frame time metric means it will give you the application how much time your how much time is getting consumed, or how much time it is taking to render a frame inside your application. Average time, and you can say how many iterations you want to perform. So obviously, if you profile it for a single time, it is not sufficient. Actually, every time it's a different situation, right? इंडिया में तो बहुत प्रॉब्लम होता है, because let's say if it is a summer, आपका डिवाइस थोड़ा स्लो परफॉर्म करना चालू कर देता है. If it is a winter, बहुत फास्ट चलता है. So बेंचमार्क में भी ऐसा होता है कि कभी-कभी rarely if you run it तो maybe सही नहीं चलेगा, तो we should actually run it via iterations. So क्या होता है कि maybe if you run it for 5 times, कभी-कभी 100 मिलीसेकंड टाइम आएगा, कभी-कभी 110 मिलीसेकंड टाइम आएगा, कभी-कभी 90 मिलीसेकंड टाइम आएगा, but you get a baseline कि इसके आसपास ही है. So that baseline you can get through iterations. So maybe whatever iterations you specify, तो उतने टाइम performance test चलेगा, उतने टाइम आपका app launch होगा and वो मेजर होगा, and then you will get perfect data from it. And inside this lambda block, you can write whatever text you want to write, like maybe start your activity, scroll करो, ये करो, वो करो, click करो. And these are the metrics which are provided by Microbenchmark. Like it gives you info of startup time, like how much time it is taking for your app to start. If you add this test, and let's say whenever some developer comes and adds something in the startup which increases the startup time, it means it's a red flag. So you will automatically get to know, like you don't have to spend special time for this. Frame time metrics we already saw. Then trace section metrics. So whatever traces we add in the application, we recently added on custom traces, like you can measure them as well inside this test. So for example, if you add custom trace, let's say screen loading time, like you add this trace. So you can actually add this trace as well there, and you can measure battery metric as well, like how much power it is consuming. I mean, this is not that necessary, but just for your information. And memory usage metric. So how much memory it is consuming whenever certain tests are running. Let's say 20 MB consumed, and let's say sometime we any developer comes and starts consuming more and more memory. So ये बढ़ जाएगा, and you can get flagged कि okay, now we have memory issues. So for example, whenever you run a test, it looks like this. So अभी हमने जो recycler view का example देखा previous slides में, if you I have already written test for it in the repository. You can see it will give you the all info of like key recycle view का bind view holder 23 times all over. It gives you a min, median, max, and फिर view holder में how much time it took. Let's say it was taking around 840 milliseconds at mean, 851 milliseconds at median, and let's say 960 milliseconds, which is almost around 2 seconds at max. फिर overall traces like on create का कितना हुआ, on bind का कितना हुआ, etc. etc. And then there is a frame duration कि 50% time, मतलब percentage we'll learn how to measure it, but let's say 278 milliseconds उसने लिए for median users 50% time के लिए, and let's say at P99 मतलब एकदम worst user के लिए it took around 4 milliseconds, sorry 4 seconds, 4000 milliseconds, मतलब 1 second अगर और चला था तो फिर NRE आ जाता directly. And let's say whenever we fixed it and when we run this benchmark, it is now showing okay, it is just taking 50 milliseconds on average for recycler view to render, very less, and at max it is just taking a second now, which was taking 4 seconds earlier. So this is how benchmark test will help you to visualize. And actually there is a utility, web utility from, there is an Android guy, the Apache 64, he has created a kind of tool for comparing the benchmarks. So you can just paste your benchmark comparison output by Microbenchmark, and it will just help you visualize before and after क्या चल रहा था. For example, before your application, by the way, this blue means before and yellow means after. You can see that this is count, so count obviously increases, but if you see the overall rendering time, before it was taking this much time, and after it was just very fast. So these tools can help you visualize whether you are doing correct or wrong. Now the main part, last part, observability. So observability means seeing what your users see. अभी तो आपने अपने डिवाइस पे कर लिया जो कर लिया, but now एंड में मैटर क्या करता है कि यूजर को क्या एक्सपीरियंस है, राइट? आपके लिए सब सही चल रहा है बट यूजर के लिए सब खराब है, तो इट इज ऑब्वियसली आर्गुमेंट. The truth is in percentiles. So actually what your average users are seeing, whether they are fine or not, your average users might be fine, but your P90 users means the slowest 10% of users could be having terrible experience. So the real user monitoring means performance observability helps you to observe the data for this worst users. मतलब यूजर को worst नहीं बोल रहा मैं, उनके experience को worst बोल रहा हूँ. So this worst user experiences. So for example, let's say तुम जब टेस्ट कर रहे हो तो तुम्हारा डेटा कुछ इस तरह है, okay, like we are doing very fast, we are able to achieve this in 200 milliseconds because maybe you are testing on Pixel 9, Pixel 10 devices. But when it comes to real user, तब आपका टाइम बढ़ जाता है, 500 मिलीसेकंड हो जाता है. फिर आपका यूजर और खराब डिवाइस यूज कर रहा है तो वो 1500 मिलीसेकंड, 3000 मिलीसेकंड तक हो जाता है. So now how to find this? So we have to break down the percentiles. So percentile is a mathematics concept जो मैंने शायद इंजीनियरिंग में पढ़ा नहीं, बट बाद में I have to revise because of this. So percentile is a value below which the given percentage of observation falls. It gives you the context about relative performance instead of absolute values. Example, if user has latency at 95th percentile, which is like 200 milliseconds, it means 95% of the queries are faster than 200 milliseconds. It means just 5% of users are falling beyond 200 milliseconds. Theory, too much theory, right? So let's say this. So for example, this is the percentile data. Here, this axis is basically, let's say, app startup time, starting from 0 to, let's say, 2000 milliseconds, and these are the number of users. So for example, this blue means 50 percentile, this yellow means 90, and this red means 95 percentile. So for example, in this 50 percentile, it is a median experience. It means half of your users are experiencing startup time of 500 milliseconds or less. It means 50% users के लिए startup time 500 milliseconds से कम है. It means rest of 50 के लिए वो 500 milliseconds से ज़्यादा है. And now वो ज़्यादा में कैसे जाएगी? So let's take a look at 90 percentile data. So this is basically, these are the kind of users which are falling in the slow experience. So let's say it is a point where 90% of users have better experience and notable 10% will have a worse one. So 90% वाले मतलब 90% users को 1500 मिलीसेकंड से कम टाइम लग रहा है. It means 1500 मिलीसेकंड तो लग रहे हैं. And फिर rest of the 10% के लिए you can see this red. So rest of the 10% के लिए फिर वो ज़्यादा टाइम लग रहा है. And there is also 99th percentile. It means कि तुम्हारे 1% users को 3000 मिलीसेकंड से भी ज़्यादा लग रहा है. I think एक यूजर के लिए तो कोई रिस्पेक्ट नहीं करता ज़्यादा, राइट? एक को हो रहा है तो इट्स वन इट. बट एक्चुअली वी शुड केयर फॉर मोस्टली दिस 90% एंड 95%. 99 इज लाइक नोइंग कि क्या चल रहा है, मतलब कितने पानी में है हमारा ऐप एंड ऑल, जस्ट टू नो दैट. अदरवाइज दिस हैपेंस. एंड फॉर दिस वी हैव टूल्स लाइक Firebase, DataDog, Sentry and many more. I will just show you the examples of how this looks. So let's say Firebase has a performance monitoring dashboard for it. It so if you are using Firebase monitoring, performance monitoring, it automatically captures your app startup time, कि कितना time ले रहा है across all your real users. It samples it as well. So for example, it will give you the अच्छा वाला graph over the time कि कितना time आपका app ले रहा है for startup time. If you see spikes, it means कि app कुछ तो गड़बड़ कर रहा है. If you see it is lowering down, it means app सही चल रहा है. And it will also give you the insights कि फिर last time से कितना faster है, कितना slower है. Slower है तो red दिखेगा. If it is fast, then it will show in the green. And if you see, it will also give you the options कि आपको कौन से percentile का data लेना है. If it's a 50 percentile, you can select 50, 90 percentile, मतलब 90 percentile का data दिखेगा. And this is your real users data. Now इस पे तो आप fully trust कर सकते हो. You can doubt your profiling, but you cannot doubt this. And this will actually give you the real insights कि actual users को क्या दिखा है. And this will also, like once you click on the more info of the trace, it will give you a sample trace जिसमें जैसे प्रोफाइल में लाइव डेरिवेटिव दिखते हैं कि कितना CPU यूज हो रहा है, कितना मेमोरी यूज हो रहा है. It will also show you कि at a time यूजर के प्रोफाइल में क्या क्या हो रहा था. Like कितना CPU स्पाइक्स हो रहा था, कितना मेमोरी अगर इंक्रीज हो रहा है तो इंक्रीज का दिखाएगा, फ्लैट है तो फ्लैट दिखाएगा. एंड एट दैट टाइम अभी आपको दिखेगा नहीं, बट यहाँ पे दिख रहा है कि मेन एक्टिविटी लोड हो रहा है, यहाँ पे कुछ API कॉल चल रहा है. सो इफ यू आर यूजिंग OKHTTP तो ऑटोमेटिकली OKHTTP या रेट्रोफिट तो ऑटोमेटिकली वो नेटवर्क ट्रेसेस भी करेक्ट कर लेता है. एंड नाउ इफ यू आर सीइंग कि ओके ऐप स्टार्ट होते टाइम अगर नेटवर्क कॉल हो रहा है तो ऑब्वियसली वो नहीं होना चाहिए. यू कैन डिबग इट फर्दर एंड मे बी improve the performance, and next time Firebase आपको बताएगा कि आपका अच्छा कर रहा है. And as I say, वो automatically network calls का भी latency check करता है कि okay जब आप टेस्ट करते हो आप staging पे टेस्ट करते हो सब तो सही चलता है, फास्ट होता है. But at prod अगर नेटवर्क भी बहुत टाइम ले रहा है तो Firebase also gives you the network का profiling automatically. You don't need to do anything. It just automatically adds an interceptor whenever you run that. And you can check okay www.google.com के लिए average load time was 441 milliseconds. Crashlytics API के लिए it is taking around 2 seconds. Playgoogle.com के लिए it is taking around 386 milliseconds and इसका भी वो percentage में data दिखाएगा properly. So ये तो हो गया network का. And screen rendering as well. This is also automatically taken. Whatever activities you have in the application, it will show how much time it is taking to render the activities. And जैसे हमने प्रोफाइलर में कस्टम ट्रेसेस ऐड किए हमारे खुद के, you can add custom traces as well. Firebase का क्लास होता है एक. So for example, these are the custom traces added by Firebase itself. But let's say if you want to add custom traces, simply you can get the instance of Firebase dot performance.new trace. Trace का कोई भी नाम दे दो. Trace start करो, perform something, trace stop करो, and then that tag will be visible. And whenever there are anomalies, let's say you added this custom trace, and custom trace में कुछ गड़बड़ी आई, तो you will automatically get email कि आपका ये जो टेस्ट ट्रेस आपने जो ऐड किया था recently, वो suddenly maybe spike कर रहा है, like it's taking you can see let's say 1 second in version XYZ at the 90th percentile. So this way you can get alerted कि कुछ wrong होता है तो. So this is how observability helps you. So this is completely different from Crashlytics actually. So this dash.
Yeah. So for example, I'm calling a function to input analytics. So is it about that, like measuring the performance of Firebase capabilities?
Yeah, you can do that as well. Yeah, and then we have a custom metrics as DataDog. So DataDog gives you more capabilities than Firebase. You can create custom dashboards and all. This is just for demo. Like Firebase में तो parent children traces देख सकते हैं जैसे Perfetto में दिखते हैं, but with DataDog you can actually see all traces in detail with जैसे Perfetto या Studio Profiler में दिखता है, literally same. But yeah, DataDog has some cost. Obviously, like consult your organization before using it. But yeah, Firebase is free. Like you can use it at any scale. So how your execution plan for performance improvement should look like? Always add measurement first. मतलब सबसे पहले measure करो कि कितना prime XYZ चीज दे रही है. Then profile it with Profiler, Perfetto, anything, any tool which you like. Then उसको improve करो. जैसे TDD cycle से हो गया. मतलब profile करो, improve करो, फिर से measure करो if it works. And then add monitoring for it for the user. And then monitor it on Firebase and DataDog जो है. So this overall cycle will give you the information कि भाई आपका फिर performance सच में success हो या नहीं. Because just sharing one experience. Sorry for taking 1 minute extra. But let's say at Paytm we did performance improvements. I was working on performance improvement for camera thing. Okay, we did improve. Everything was working fine on my device. Like it improved around 20% of performance. But when it got to production, okay, performance fix was like कि कुछ चीज main thread पे बहुत टाइम ले रही थी तो हमने उसको background thread में डाल दिया. And after that, most of the 90% of users के लिए वो improvement successfully हुआ, but 10% user जो slow device use करते थे जिसमें सिर्फ quad core मतलब 4 GB RAM 2 GB RAM devices थे, उनका time बढ़ गया because background thread is not solution for everything. क्योंकि फिर when we switch from main thread to background thread तो उसका भी context switch का cost होता है. And application के पास सिर्फ 4 ही CPUs है, मतलब let's say 4 core से quad core, और इसको हम बोले कि भाई तुम ये भी काम करो वो भी काम करो तो वो नहीं करेगा. Like actually multi-threading मतलब parallel में नहीं चलता, right? Like it's always concurrent. कुछ तो भी बंद रहेगा फिर दूसरा कुछ execute होगा. It's always concurrent. So this is how it helps you to debug the issues. Otherwise, if we do not have observability at scale, then हमें पता ही नहीं चलता कभी. Then later we did fix for this low-end users as well, and it worked. So yeah, it's complete cycle. It will keep on evolving when you work on performance. And I think every company should have मतलब एक performance का एक unit होना ही चाहिए जो constantly work करता है on improving the performance. So it's endless cycle. Detect, analyze, reproduce, debug, fix, and deploy. Goes on as you get the issues. So yeah, takeaways are like always profile early and profile often. Automate it with benchmark so that you don't have to perform it again and again. So with that you can confident as well. Use the right tool for your job and always use the real user's data. And for the manual debugging, you can use these tools which you already saw. For the automation testing, use Microbenchmark. Microbenchmark is another tool which maybe you can take a look how it looks. And for production monitoring, you can use Firebase, DataDog, Crashlytics for out-of-memory errors and cleaners, and anything, any other tool, third party. Like so there is also a library called jank stats, जो आपको बताता है कि कितने janks के application आ रहे हैं. It is I think early library. So that's all. And now you are ready to improve the app performance.
Yes.
Yeah. So yeah, this kind of talk seems boring, but yeah, once you start looking into take a look into performance, it will find interesting to you. Like you will find a joy in it. And at the end, जब performance improve होगा ना, तो सच में वो dopamine effect काम करता है इसमें. So yeah, if you have any questions, we can take or like. Okay, we'll take it later, or maybe I'm here till the end of the event. We can anytime wait. So yeah, these are some resources. I will share the slides. And thank you so much.